Thank you, Mr. Chairman. And thank all of you here. This has been very interesting once again. Now, what are, and I guess I'll ask to all of you, what are the unexamined big data challenges that could benefit from machine learning? And what are the consequences for the U.S. for not being the world leader in that if we aren't going forward in the future? Maybe Dr. Rollett, if you'd like to start. You looked like you had an answer ready to go. So.
I'll give you a small example from my own field. So when we deal with materials, then we have to look inside the materials. So we typically take a piece of steel and we cut it and we polish it and we take pictures of it. So traditionally, what we've done is play the expert witness, as it were. You look at these pictures, which I often say resemble more a Jackson Pollock painting than anything that remotely as simple as a cat. And so the excitement in our field is that we now have the tools that we can start to tease things out of these pictures, that we go from something where we were completely dependent on sort of gray-bearded experts to let the computer do a lot of the job for you. And that speeds things up, and it automates them, and it allows companies to detect problems that they're running across. So it's just one example.
Excellent.
Congresswoman Comstock, thank you for the question. I have two sort of answers, specifically to thinking about brains and then to thinking about education. I think these are the potential things that we can lose. One of the things that I find fascinating about how our brains work is that whether you are Einstein thinking up a relativity or Mozart making a concerto, or you're just at home watching reality TV, all brains operate at about 20 watts of energy. These light bulbs in this room are probably at 60 watts of energy. And although you might already think some of your colleagues are dim bulbs, in this sense, in this sense, what's amazing about the things that they can accomplish is that they accomplish them at energy efficiencies that are currently unheard of for any type of algorithm. So I feel like if we can leverage machine learning, deep analytics, and understand how the brain passes information and processes information for energies that are really unheard of in our energy efficiencies unheard of in our current algorithms and robots, that's a huge benefit to both the national and economic securities of our country. That's the first. And the second thing I'd like to add, the other reason that it's important for us to lead now, and I'll do it by example, is that in 1962 at Rice University, John F. Kennedy announced that we were going to the moon. And he announced it, and in his speech, he said, we're going to go to the moon, and I paraphrase, not because it's easy, but because it's hard, and because hard things test our mettle and test our capabilities. The other interesting fact about that is in 1969, when we landed on the moon, the average age of a NASA scientist was 29 years old. So quick math suggests that when Kennedy announced the moonshot, many of these people were in college. They were students. And there was something inspirational about positing something difficult, positing something visionary. And I suspect that this has benefited us. Recruiting this generation of scientists to the moonshot has benefited this country in ways that we yet haven't calculated. And I suspect that if we don't move now, we lose both of these opportunities, among many others.
So it's really a matter of getting that focus and attention and commitment so that you have that next generation understanding this is really a long-term investment and we have a passion for it, so they will.
Exactly.
I'll just add briefly that I think we really want to, in terms of the threat associated with this, is really about continuing to be a leader in computing, but also about the control and use of information. And you can see how kinds of examples we've given are really important, and you hear about it in the news about the control and use of information. We need leaders in understanding how to do that and how to and make sure that information is used wisely. We teach our freshmen at Berkeley a course in data science. So whether they're going to go off and become English majors or art majors or engineers, we think it's really important for people to understand data.
And just real briefly, I'd like to build a little bit on Dr. Rollett's comments. For us, we're seeing tremendous benefit in big data for things like trying to better predict when an aircraft engine part has to be repaired, when it needs to be inspected. Very critical for the safety of that engine. For gas turbines, same thing, when parts need to be inspected, repaired. So where does big data come in? It comes in with computational fluid dynamics, which we leverage actually the high-performance computing infrastructure of the U.S. Material science, material knowledge, trying to understand grain structure, et cetera. So for us, that nexus of the digital technologies with the physics understanding the thermodynamics of our assets are leading us into what I think is just a better place to be from maintenance scheduling, safety, resiliency, et cetera.
Thank you. I really appreciate all of your answers. Yield back.